Okay, in our earlier sessions, we've learned that the correlation coefficient squared tells us the percent of variation explained by the relationship between two variables. What this session is going to be about is you don't make the mental leap to say that that is also the percent of the variation caused by the relationship between two variables, because correlation does not imply causality. And we're going to talk about how you actually should be using correlation to understand your data. Here are the three things we want to talk about. First is, when you see a high correlation, there's a story that will explain that. And we're going to talk about the different reasons why you might see high correlation. And one of them is causality, but there are many others. So we don't want to assume automatically that if two variables are correlated, that one causes the other. The bigger picture goal here is, in general, when you're doing data analysis, you want to start with your existing subject matter expertise. For example, you already know that a bigger house is more expensive. So when you're computing a correlation coefficient between square foot and the selling price of the house, all you're doing is using data to quantify the expertise that you already have. When X and Y are correlated, it could mean that X causes Y, or the causality could go in the other direction. And here's a silly example of what would happen if you got the causality going in the wrong direction. And here is another possibility. The two variables could be connected through a third variable. Sometimes that's called a lurking variable. For example, I would assume that people who spend more money on vacations also spend more money on cars, because you tend to spend more on each the more wealthy you are. So the lurking variable would be the person's wealth. There's no real causal relationship between going on vacation and buying BMWs or vice versa. There is a correlation between the crime rate and the sales of ice cream, because both go up when the temperature is warmer. And lots of times correlations are just spurious or accidental, and that's particularly true when you're dealing with time-ordered data. If you take a one-time series, say professor salaries that have increased over time, and you take any other time series, consumption of drugs, for example, that has also increased over time, then they will show a positive correlation. And if you look at enough different things, you will be able to find some of these spurious correlations that are very high. Here's an example where the correlation coefficient is over 0.99. Two other ways you can get high correlations is use data where the sample size is small, and quite often, just by chance, the points will show correlation. Or the other thing is, take a spreadsheet that's got 100 columns in it and compute the correlations for all the different pairs in there. Some of them will be big, and it's probably just an accident. Here's an example where two things happen. One is somebody had a lot of time on their hands and just looked at a lot of different data sets probably. And second, they found a data set that was fairly small. There's only a dozen or so observations. And they found a very high correlation between two things that are obviously not linked. So here's all I want you to get out of this session. When X and Y are correlated, there are lots of different explanations. In fact, they can be categorized into four categories. X causes Y, Y causes X, X and Y are linked by another variable, or the correlation is just due to chance. And the fourth explanation is one that's highly likely if there's no underlying understanding of the subject that led somebody to actually investigate this particular correlation. In practice, what I would want you to do is to say, I'm going to think like a scientist. I'm going to start by saying my understanding of this is such and such, and let's see if the data supports that. Okay, thank you. That's all for this session, and I hope it didn't sound too much like preaching and carping, but it's something you need to always keep in mind when you're looking at data.